have very little manpower. The data gathering we are doing is done by UC San Diego, and that's the solar radiance maps.
Yeah,
and they are trying to get this on a smaller scale, so a finer scale, if you wish, which will be useful, of course, for knowing what the possibilities are for putting in plants in local areas.
Yeah, in fact, Jan Kleisel at UC San Diego helped host a large RD&D collaborative meeting that we had a couple weeks ago.
Yeah, and his data is available on his website.
Yeah.
Well, it's probably worth mentioning that this California solar data is available for the entire state now. That's publicly available through the CSI program.
Oh, you mean this California solar statistics?
The high resolution solar.
Oh yeah. So Tom Hoff is saying that high resolution solar irradiance maps have been made available through Tom's project, which is available through the whole state, which brings down solar irradiance to the 1K kilometer to 1 kilometer level. It was previously only available at the 10K by 10K level. So that's a serious increase in the availability of information. So it's things like that. Those are, again, similar, like it's a resource mapping project, just like the wind folks need resource maps and geothermal. Everybody needs resource maps, so that's why we worked on that on the solar side. Sir?
Yes, I just had one comment on this grid optimization that the panel was talking about research-wise. I don't know that I fully understand exactly the concept, but in terms of the audience that research would be addressed to, it looks as though you're talking about a fairly large geographic scope, since there would be multiple different renewables involved. I don't know whether you would be looking at, the optimization statewide or in a particular region, but it doesn't look like it's research that would be directed at necessarily a specific industry. Like it would be more directed at policymakers who would be looking, or consultants who are designing power systems for large regions that rely on multiple renewable resources. So I was thinking that I would just suggest, if that's the concept or anything sort of close to it, that it would be useful to have the research in a form that is a model of some type or an example. This is what really works with policy people a lot of times in my experience. So in other words, to see, maybe take the Sacramento region or San Diego or whatever, and apply that research on multiple alternatives resources to that region, so that we would be able to see, okay, here's how you could really do renewable energy effectively on a regional scale, relying on multiple alternative energy sources. I don't know, there may be some research out there, obviously, that's headed in that direction, but I think that that kind of modeling example would be very useful, actually a little bit more useful than the financial aspect of it, because I think we know the marketplace is going to, be analyzing the cost and benefits of all these different technologies and working that over a period of time. So I don't know if you have any further on that point, but I think a model or an example is the easiest thing to hook up with. Thank you.
This is Steve Kafka. I agree with you about having good examples. I mean, I think I personally learned from them. The Biomass Collaborative, under its current peer contract, has a biomass management zone project that we're working on that basically draws polygons and looks at diverse sources of biomass within the region. We have not been able to extend that to other sources of energy, but it would form a good basis for doing so. So it's a great suggestion.
Just to follow on, there's a report that's going to be coming out very soon, if it hasn't already appeared, and Jerry, you may know BOA 248. Is that out yet? There was an attempt made this last year to look at the LA Basin and the Imperial Valley to identify where co-located resources existed in terms of biomass. Biomass was not included. geothermal, but we still like you. Geothermal, solar, and wind, to find out at high resolution where were co-located resources. And that was as a first step toward trying to identify how might we develop that further into something that would let us know what the combined resources could be, how they could be used, what the opportunities might be to develop those. So we're moving in the direction of doing it on a community resolutions, community scale resolution, and doing it across the spectrum.
Yeah, I'd just like to add that's an excellent point. In the studies that I've been engaged in the past at the state level, there's been a lot of effort initially put forward in establishing a good methodology and then vetting that. And typically that leads to some public workshops, some very spirited public workshops, but it does iron out the process a little bit. And then applying those to smaller control areas or service territories first before applying it to something larger like PG&E or Southern California Edison or the Cal ISO control area.
I'm not sure this will be a good answer to your question, but chemical engineers are always involved in process control issues. They run very, very complex plants where, as I mentioned earlier, there may be several optimizations that can be possible for running the plant. And they do this with process control software that has been developed over many, many years, where you have a minimal of data coming into the system, because to get data into the system of a large plant costs money. You could, of course, put pressure meters and temperature meters all over the place, but that would make the control issues more complex because you get too much data in. So what has evolved over time is to be able to control the process as there are variations in the process all the time, to make sure that the product is produced at the purity that's specified and at the production rate. So I think these kind of that kind of work, some of the chemical engineers are now applying to grid optimization problems, where you have a lot of inputs and variable inputs, and at the same time you want to produce a constant source of electricity.